Yes, but I've got something to talk to you about that too.
You said we had little homework this chapter.
This is like one of the last ones.
One of the last ones.
I think we. Hold on. I think. Let me see what we got in terms of. Let me see what we got in terms of next week. I didn't lie to you. So, on Tuesday, you have a quiz. Wednesday, last section of discussion, and we got some demos to do. Thursday, review. Friday, test. So this is your last homework for this chapter. For this chapter. Like I said, I'm trying to not do the paper airplane. I'm trying to do a bigger, ramped up version of it.
So card stop.
Oh, you're doing the test? That's fine. We'll talk. Actually, you won't be here Tuesday, so we can talk Wednesday and get something figured out for you.
Wait, when is it? Wednesday or Tuesday?
The quiz is Tuesday, but
Calc is Tuesday. For English.
We're just skipping the quiz because we'll be taking a very
We're gonna be doing a lot.
how about I want to get us. How about this? I'll just turn it into a homework assignment, like a 4 or 5 question homework assignment. Okay.
Is it worth how many points?
I'll still make it 20. That way you're not losing the points. But again, it'll be a lot shorter of a. But and I mean, it's take home. I know what you guys do with your take home stuff. What?
Diligently.
Uh-huh.
With no electronic.
Dare you question the real world has resources.
I mean, if you're not using any technological advances that you could have, you're kind of slacking. So, I mean, the old Google wasn't Google back when I was there. I was actually in the library until 12:30 most evenings. So, yeah, if you can TikTok and Snapagram and all that stuff, you can look up information. All right. Section 2 has us looking at fluid pressure. Now, in a few years, when I watch this video, it's like TikTok, just like what was mine? Okay. In this section, we're going to calculate the pressure exerted by a fluid, calculate how pressure varies with the depth in a fluid. We're actually not going to calculate, we're just going to discuss it. And then hop right in. So, first formula is pressure, which is the magnitude of the force on a surface per unit area. So P is equal to F divided by A. You probably remember this equation, if not from earlier in the year, but also if you took honors chem a couple years ago in chapter 10, we also give the same equation talked about air pressure. Okay. We are going to utilize Pascal's principle in this section. It states that the pressure applied to a fluid in a closed container is transmitted equally to every point of the fluid as well as the walls of the container. So, Pascal's principle gives us this formula. What we're going to be looking at is really how placing pressure on one surface area, example of a piston, is going to allow us to provide another varied pressure on a different surface area in a secondary location. So much like what we see in the video where they talked about pistons, say of a car jack or even like a barber's chair, okay? Those are all utilizing Pascal's principle to help input with less pressure to lift or move a larger pressure or force, okay? So, hopefully you all got that written down. So we're going to hop right into the calculation. So the small piston of a hydraulic lift has an area of 0.20 meters squared. Notice the units that I'm using as well, okay? A car weighing 1.20 times 10 to the 4th newtons sits on a rack mounted on the large piston. Large piston has an area of 0.90 meters squared. How large of a force must be applied to the small piston to support the car? So as you are going through these equations, or sorry, these formulas, problems, there we go, you have to start identifying who is belonging to whom, Okay. So the small piston, we were told, we'll label that A1. We see its volume or its area. We know the area of the second larger piston, and we know the force or the weight of the object being lifted. So what we are trying to find is the initial force, the F1 that is placed on the small piston. Okay. So taking Pascal's principal formula and rearranging it to find F1, we get F2 times A1 is going to be divided by A2. So putting that into practice, find our force needed on the small piston. Again, our F2 was the weight of the car, 1.2 times 10 to the 4th newtons. The area of the first piston was 0.20 meters squared, divided by the area of the second piston, 0.90 meters squared. What do we get for our force that we need to apply? Monmouth College.
I'm not there. Three forces.
3 forces. Actually, the number's not too far off. Well, kind of, sort of not. Ish. We got time.
Uh, 2,666.66.
Easy there, Devil. Let's change that number. 2.7 times 10 to the 3rd newtons. That sounds better. So again, as you can see, a significantly smaller amount of force is required to apply. This is what we call a force multiplier. Okay? This is what hydraulics does for us. Next, open up your books to page 200 and something. 200 under practice B. I forgot to write the page number down. It's near the 280s, I think. Um, 282. I'm gonna write that down. Okay. Let me get out of here. Bring in my little camera. Okay. Now let's look at question. Let's look at question number 2 real quick. Says a 1.5 meter wide body, wide by 2.5 meter long waterbed weighs 1,025 newtons. Find the pressure that the waterbed exerts on the floor. Assume that the entire lower surface of the bed makes contact with the floor. So in this case, we're not using Pascal's principle. What are we using? We're using pressure is equal to force divided by area. So what do we know? Well, we're trying to figure out what pressure is, okay? The force exerted on here is the weight of the bed, so 1,025 newtons. What's our area? We're not given our area. There we go. We're not given the area directly, so we have to find it. 1.5 meters times 2.5 meters gives us what? 3.75 meters squared. So now we just simply plug everything back in. So we get 1,025 newtons over 3.75 meters squared. And again, we are measuring it in pascals. Okay? A Pascal has a measure of Newton per meter squared. So when you calculate this, you should get 2.7 times 10 to the second Pascal. Okay, let's step it up a little bit. Let's go back to number 1. Numero uno. Okay. So 1A. So in a car lift, compressed air exerts a force on a piston with a radius of 5 centimeters. This pressure is transmitted to a second piston with a radius of 15 centimeters. A asks how large a force must the compressed air exert to lift 1.33 times 10 to the 4th Newton car. Well, first, let's write what we know. We know that the radius of the first piston was 5 centimeters, but we need to have it in terms of meters. So we need to convert that, and we're going to have 0.05 meters. We know that the radius of the second one was 15 centimeters. Again, we need to convert that to meters. To 0.15 meters. Now, you might be saying, well, those are meters and not meters squared. Well, we've got to determine what our area is. Okay, so we're going to come to that here in a little bit. We also know that the weight of the car, so F2, that we need to lift is 1.33 times 10 to the 4th newtons. So we need to find F1 again. So if we take the formula, F1 over A1 is equal to F2 over A2, and rearrange this to solve for F1, we get F1 is equal to F2 A1 over A2. But we don't know the areas. How do we find the area using a radius? Pi r squared. So we're just going to substitute in those equations for A1 and A2. So we get, move my camera. We get F2 pi r1 squared over pi r2 squared. But how can I simplify this? You notice a common thing that I can maybe remove? So I could just use this equation now to help us solve. So placing my numbers in there, again, my F2 was 1.33, that's a weird looking 3 times 10 to the 4th newtons times 0.05 meters squared divided by the second radius of 0.15 meters, but again, that is squared. So what force must be input, excuse me, to solve for this, or to move the car? Okay, and if we simplify that to scientific notation, we should get a rounded number of 1.48 times 10 to the 3rd. Thank you. Now let's figure something else out here. Let's look at part B. Part B says, what pressure produces this force? Neglect the weight of the pistons, okay? So we are going to look at the second piston, okay? So the F2 and A2. And so just like this. But again, we have F2 over pi R2 squared. So we take the weight of the car, 1.33 times 10 to the 4th newtons. Multiply it by, or sorry, divided by pi times 0.15 meters squared. So what pressure in pascals will be exerted on the second piston? Put in scientific notation. Second piston. Yeah. It's discussing lifting the car. So yeah. I like that answer. And it's in pascals. So in these examples, we've used Pascal's principal formula. We've used the pressure formula. We've kind of tossed in some different ways to calculate the areas. If you have any questions, that's what your homework is going to focus on, is solving problems just like this. And your homework, although has to be completed by individuals, you may work with other people. So although this is stapled, there are only 11 questions. They give you some example problems for each different type of setup that you may need. Really not lengthy concern. Hey, JD.